I apologize for the abrupt end to our last video. I ran out of space, I believe, on my Surface Pro, and it kicked me out. So I deleted a bunch of videos, and here we go again. We were just starting to solve number 12 on our 5-2 practice. I multiplied everything in that first equation from my system in number 12 by -4. And then I'm just copying down the second equation because it is already set up and ready for me to add the z variables to 0. That gives me a -5x plus y equals 1 as my fourth equation in this system. And then when I look at, I can add equations 1 and 3 together and multiply equation 1 by a -3 to get z to add to 0 again. I'm not changing the third equation. This gives me my fifth equation as -2x, z's add to 0, plus y equals 1. So I have two different equations. They both have a y. So I can add those two equations together. I'll just multiply the first one times a -1. Equation number 4 times a -1 gives me 5x minus y equals -1. Leave equation 5 alone. -2x plus y equals 1. When I add that together, I get 3x, y is added to 0, equals 0. Which gives me an x value of 0, which was what I expected because I already gave you guys the solution set for this. Well, if x is 0, then I can take that 0 and I can plug it into equation 5 or equation 4. And that would be -2 times 0 plus y equals 1, which means that y equals 1. So I have x and y. And then I take those two values for x and y and I plug them into any of the three equations in my system. Let's just plug it into the first equation. That would be 2 times 0 because x is 0, minus 1 because y is 1, plus z equals 1. So I have 0 minus 1 plus z equals 1. When I add that 1 to the other side, I get that z equals 2. And that was the expected solution, ordered triple solution for that system. All right, let's talk about the last page. I hate that I had to split that video into two pieces just for about 5 or 6 minutes, but there we go. Okay, we're going to introduce the concept of back substitution. Now, back substitution is what we're going to use when we move into chapter 6. When we start talking about matrices, but it's always good to think about things ahead of time. Now, a matrix is going to be an organized array of numbers to represent our systems of equation. We're not going to write a matrix right now, but if I were to write this as a matrix, I wouldn't write down the variables. I would just write the coefficients. As we move toward using matrices, that's a way that we're going to solve systems without rewriting those variables every single time. We use a concept called back substitution. This system is set up so we can use back substitution, and that makes it pretty easy to find the system. This concept of back substitution makes our system really easy to solve. If you look down the list of equations, I have z solved for. I know that z is 5. So I can work backwards and substitute this in and work my way up to finish solving the system. If I know that z is 5, then I can say, you know what, that means y plus 2 times 5 equals 13. So y is 3. And then I can take that knowledge, knowing that z is 5 and y is 3, back up again and plug it into the original equation, or the first equation, not the original equation, but the first equation, and say x plus 3 plus 2 times 5 is going to give me 19. So x, and then that's 10 plus 3, x plus 13 equals 19. So x is 6, and my ordered triple would be 6, 3, 5 using back substitution. Now, my keys that I have back substitution are that I have eliminated a variable from each successive equation. That's how I know I can use back substitution. Look at the next system. The next system of equations, 4 equations in 4 variables. But because it is back substitution, it makes it super simple to solve. I want you to use that idea of back substitution. Now we have fractions, so I'm going to go ahead and I'm going to kind of walk you through this. This fraction is 8/3. This fraction is 1/3 if it's difficult to read. So I'm going to start with this z equals 3, and I'm going to work my way back up. Z equals 3. So y minus 3 equals 1 means that y equals -2. Nope, y doesn't equal -2. Y equals 4. I really need you guys here with me. Keep me honest. Y equals 4. So z equals 3, y equals 4. We're looking for w, x, y, z as our ordered 4 variable system. So we've got w, x, y, z. We know that y is 4, w, x, y, z is 3. So we have the last 2 values. We need to find w and x. So I know z, I know y. I'm going to go back up again and I'm going to solve for x. So x equals 1/3 y plus z, and that is equal to 8/3. So I've got x, not x equals, x minus 1/3 times 4, because 1/3 times y, plus z plus 3 equals 8/3. So I've got x minus 4/3 plus 3 equals 8/3. You want to know an easy way to deal with those fractions? Eliminate the fractions. I'm going to multiply everything by the denominator. Remember, if I multiply both sides of my equation by the same thing, that's a legal move, arithmetically speaking. So I can distribute this 3 inside here. That gives me 3x minus 4, because 3 times 4 is 12, divided by 3 is 4, plus 9 equals 8. That is 3x plus 5 equals 8. If I subtract that 5, I get that 3x is equal to 3. So x is 1. X is 1. Now all we have to do is solve for w. Solving for w, I go back and I look at my very first equation in the system, and I have w, that's my unknown, minus x plus 2 times y minus 2 times z equals -1. Well, w minus 1 plus 8 minus 6 equals -1. Right here, 8 minus 1 is 7. 7 minus 6 is 1. So w plus 1 equals -1. So when I move that 1 over, I get that w is equal to -2. And we have solved our 4 variable system. Now, the most important thing that I want you to take, 2 most important things. First of all, back substitution. Getting the hang of back substitution. If I can simplify down by 1 variable each time after I know this last variable, I can work my way up. The next is how to deal with fractions. If I have fractions within my system, all I need to do is eliminate that denominator by multiplying everything by the LCD. That only works when I have an equation.